Hi everyone, good evening. So let me share my screen. Assume that you can see my screen now. You can see my screen now. So in last session, we discussed about operators. So we discussed about the arithmetic operators, string concatenation operator, assignment operator, then increment operators, decrement operators. We discussed about relational operators, logical operators, new operator. We discussed about till new operator. So so we will discuss about we'll discuss about the eighth operator, which is okay. So it is instance of operator. It is instance of operator, and then we have then we have ternary operator, ternary operator, and then finally we have bitwise operators. Bitwise operator. Okay. So these are the three operators that we have. These are the three operators that we have, which we need to discuss today. Okay. Okay. So we'll discuss about the instance of operator. Okay. So instance of okay. So basically the instance of operator, okay, the instance of operator explains us the object belongs to that particular class or not. Assume that, okay. So basically the instance of operator, this operator explains us, okay, this operator explains us if the object belongs to that specific class or not, belongs to that specific class or not. Simple to say. Okay. So so assume that assume that okay. So you have a object called an animal. You have an object called animal. So which means you have a class called animal. Okay. You have a class called animal. Now what I will do is what I will do is okay. Uh, I I have another class called dog. Another class called dog. Think that. Another class called dog. So now I can verify this dog object. Okay, this dog object is an instance, is an object of animal or not. This comes under this category or not. Okay, the dogs will fall under animal category or not. I wanted to test it. I wanted to test it. For example, when I say animal, dog will dog will fall under animal category or not? Yes, it falls under dog. Dog will fall under animal category. For example, if I take a class which is cat, which is cat. Now this cat class or this cat object will fall under the category of animal or not? Okay, yes or no? Someone has to verify it. Someone has to test it. Someone has to test it. Who can test it is the instance of operator will test it. Using this instance of operator, we can explain if the objects belong to that specific class or not. Okay, it belongs to that specific class or not. For example, when I say Anil, okay, when I say Anil, okay, so now Anil will fall under this animal category, yes or no? No, this will not fall under animal category. right? It will not fall under animal category. Someone has to explain, some operator has to explain your JVM that, okay, this belongs to this specific type and this belongs to this specific type. Okay, so who is that? Who is that which will explain is the instance of operator. The instance of operator. Okay, so the instance of operator, will explain if if the object belongs to that specific type or not, that specific class or not. Okay, okay. And to remember, if you want to use instance of operator, if you want to use the instance of operator, there must be some relation, there must be some relation, there must be some relation between the classes, between the objects, between the object and classes. Without a relation, without a relation, okay, you cannot explain, or you cannot categorize these objects. You cannot categorize these objects. Okay, the instance of operator will explain that if the objects belongs to that particular class type or not, that particular class type or not. So the instance of operator, when you are using, there must be some relation between the objects. There must be some relation between the objects. For example, if I take dog and animal, there is a relation between these two. Cat and animal, there is a, we can say cat is an animal, right? Dog is an animal, right? There must be some kind of relation between, there must be some kind of relation between these objects and classes. If not, you cannot use the instance of operator. If not, you cannot use the instance of operator. So the instance of operator, do remember, this we will discuss in when we discuss about inheritance. We'll discuss about inheritance. Okay, when we discuss about the inheritance topic, we'll again revise the instance of topic. Okay, so this operator we will again revise it. For now, just remember the instance of operator will explain us if the object belongs to that particular class or not, that specific class or not. So the instance of operator must must need some relation between the objects and classes. Without having any relationship between this, okay, objects and classes, you cannot use instance of operator. You cannot use instance of operator. Okay, so I'll showcase one example for this. So here I'll go to practice. So I'll open the arithmetic check now. Now I'll create one object, arithmetic check ch is equal to, I'm using new operator and creating an object for it. So I created an object for, so which means I allocated one new memory, a new memory is allocated for this arithmetic check object. Okay, so now a new object is being created. Now what I can do, I can check the relation between this ch, this object variable ch, and this class and this class. So system.out.println of. So first I have to take the object. The object variable is ch. So instance of the class. So now I'm verifying, or I'm checking the relation between the ch variable. I'm checking the relation between the ch variable and this arithmetic class. Is it of this arithmetic type, or it is of something else, So now I'm saving this and I'm trying to compile the code. The code has compiled and trying to run this. See, the instance of operator will always return the Boolean value as the output if it belongs to that particular object, or if it belongs to that particular class, then it will return true. If that belongs to that particular class, it will return false. So now, for example, instead of arithmetic check, I will just pass it as a string. So I'm saying ch is a variable. So ch is an object of string type. No, it is not of string type. It is of arithmetic check type. Ch is a object of arithmetic check type, not of string type. Now, in this expression, what I'm saying is ch is an object of string type. Okay. Now, ideally, the ch is not of string type. It should return us the false. So I'm trying to compile the code. See, now when I try to do this, incompatible types. The reason why it is saying is, okay, there is no relation between the string and arithmetic check. There is no relation between string and arithmetic check. Okay, there is no relation between these two classes. So now the instance of operator, it is saying it is incompatible types. So for now, I'll not make any relation. I'll take the same class. Code has compiled, executed. Okay, code has compiled and executed. Okay, so instead of that, I'll take it as an object. Okay, ch is an instance of object type. I'm saying object type. What is this object? You'll understand. Ch is an instance of an object. I'm saying. Okay, this arithmetic check is of object type. I am saying object type. Now let us try to compile this. The code has compiled, which means there is a relation between this arithmetic check and there is a relation between this class, this object class. There is one class called object. So the instance of variable, it's a binary. Instance of operator is a binary operator where it takes the variable as an input at one end and the class name as the input at the second end. So points to be remembered. So now there is a relation between this arithmetic check and there is a relation between this class. There is a relation between this arithmetic check and object class. How this has come, we will discuss in the coming classes. Okay. For now, remember that there is a relation between these two classes. So you have it has written true as a response. Okay. So here are the rules. For the instance of variables, here are the rules. If possible, note it down. Instance of operator is a binary operator. It's a binary operator because, okay, one of the operand must be a variable of reference type. Okay, it must be a variable of reference type. Now, okay, one of the operand must be a class type, must be a class type. So one operand is a variable and another operand is a class, and another operator is a class, and another operand is class. Okay. Instance of operator, okay, depends on the relationships, depends on the relationship between objects. And finally, if no relations, if no relation found, if no relation found between objects, if no relation between found objects, then you will have compile time errors. You will have compile time errors. So these are the rules for instance of operator, instance of operator, and we'll reuse this instance of operator when we are dealing inheritance, when we are dealing inheritance. Okay. So basically the of operator required to find out the relation between the objects, to find out the relations between the objects. Main use of, okay, main use of instance of operator, okay, it is used to find the relationship between the objects, between the objects. So that's about the instance of operator, that's about the operator. Okay. So operator that we have, the next operator that we have is ternary operator, ternary operator. So the meaning ternary operator, okay, the ternary operator here indicates, okay, here indicates it is a combination of three conditions. It's a combination of three conditions. Okay. So what is the ternary operator is? The ternary operator. So what is the symbol for ternary operator? The question mark. Question mark symbol is called as the ternary operator in Java. The question mark is called as ternary operator. So you see that every symbol or every sign that you have in your keyboard is having some meaning defined in the programming, some meaning defined inside your programming. Okay. So when you find a question mark, which means it's a ternary operation. Ternary operation means combining, okay, combining two or combining two or more conditions, two or more conditions as a single unit, as a single unit. Okay. So so here you are combining two or more conditions, two or more conditions to evaluate the result, to evaluate the result. And do remember ternary operator, the ternary operator take only Boolean as input, Boolean as input. Okay. So by default, it'll take the Boolean as input. Okay. Or else it evaluates based on the conditions that you have on the ternary operator, based on the conditions that you have on the ternary operator. Okay. So basically, instead of writing 10 lines of code, this is like a shortcut notation. Okay. For example, I'll just give you an example. I wanted to find out, you know, uh, For example, I wanted to find out any even number and odd number. Okay. So I wanted to find if the number is even or odd. Think that I have an input called number. I have an input called number. So the number value is 10. Assume that the number value is 10. So which is of int type, which is of int type. So now I wanted to know I wanted to write a logic for this. I want to write a logic for this to know this number, as even number or odd. Is it an even number or an odd number? So I have to write a logic for it. Okay. I have to write a logic for it to find out this number as a even number or a odd number. For this, basically, you have to evaluate, or you have to do some calculations. You have to do some calculations and find it out. So what is the rule for even number? What is the rule for even number? So when you divide any number by 2, the remainder should be 0. The remainder should be 0. So I can say number modulus by 2, right? Modulus by 2. So exactly equals to 0. Double equals is a comparison. Okay, it's a comparison. It is not assignment. Double equals is a comparison operator. Okay, number ampersand by 2, which means any number divided by 2, if it is exactly equivalent to 0, then I can say as even. Okay, else the number is odd. The number is odd. I can say simple, any number that is not divisible by 2, or which remainder is not coming as 0, that maximum it goes as an odd number. That maximum it goes as an odd number. So now I wanted to simplify this condition. So you look at this logic, how many number of code that I am writing. So I have not written the exact code now because we didn't deal with if else blocks and all, right? So now what we are doing is, okay, you look at the number of lines of code that we have written. Look at the number of lines of code that we have written. It's like at least 5 to 6 lines of code we have written for this. 5 to 6 lines of code we have written for this. What if I can do the same thing in one single line? Okay, what if I can evaluate or validate all this in a single line, right? So something like this. I have a number ampersand by 2, so equal to 0. Okay, which is equal to 0. Okay, this is the expression I wanted to validate. Okay, if it is equal to 0, then written as even, or else written as odd. Simple. So you see the 6 lines of code I have shortly divided into one single line using the ternary operator. So whether it is even or odd will be decided based on this expression. If the number is divisible by 2, and if the remainder is 0, it will pick the first value. If the remainder is something else, it will pick the second value. Simple, right? Simple. So you see that the 6 lines of code I have converted, in a short notation, I have defined it as one single line of code. So basically, the ternary operator will take an expression and will take as an expression as an input, and it will evaluate the results. Based on the results, it will take a decision. This question mark is called ternary operator, where this ternary operator takes 3 operands, at least 3 operands. One is the expression to evaluate these conditions, right? So I have not written the complete code here. I just explained here the logic. So if I wanted to do this with the logic which I have said, I have to I have to write at least 10 lines of code. I have to write at least 10 lines of code. So that 10 lines of code, you think about, at least you 1 second to read it, 1 second to read it. So even the same thing happens for the compiler also, right? Even the same thing happens for the compiler also. So the readability of the code will be decreased. Readability of the code will be decreased here. Number of lines of code increases, the readability decreases. The number of lines of code increases, readability always decreases. Same, now it is simply simplified in a single line with the help of ternary operator. Ternary operator. So I'll write both the logics. I'll write both the logics. Ignore what is this if else now. You see that I have a number of integer type which is of value 10. Value 10. So the logic is, if, forget what is this logic I'm writing. Okay, just focus on the expression. The number divisible by 2 is exactly equivalent to 0. Is exactly equivalent to 0. Then I'll just print it's a even number. It's a even number. So for that I'll use a concatenation here, number plus, okay, is a even number. So whatever the number I am giving, 10, for example, 10 is a even number that it comes if it is divisible by 2. If not, if it is not, so if it is not means else condition. I am writing an else block. Else, I'm just saying this is a odd number. This is a odd number. One more closing for method and class. So here the number I have taken 10 and I'm validating the condition here. If the condition is validated successfully, then it will print this as a even number. If the condition fails, then it will print as odd number. Then it will print as odd number. That's the logic that I have written. So let me try to compile this. Okay, there is a problem. It's not minus, equals. You see the code has been compiled. Now I'm executing it. Say 10 is a even number. 10 is a even number. It is exactly divisible by 2 and the remainder value will come as 0. Number ampersand by 2 will return the remainder value as 0. 0 is exactly equivalent to 0, which the condition has evaluated as true, and it is giving 10 as an even number. 10 as an even number. So if I make this as 9, if this make an 9, so number 9 divisible by 2, the remainder value is 1. 1 is exactly equivalent to 0. That is what I'm saying here. 1 is exactly equivalent to 0. No, 1 is okay. Not 1 is not equal to 0. So this condition fails. Then it goes to the else block and it will print 9 number is a odd number. 9 number is a odd number. Compiling the code. See, 9 is a odd number. 9 is a odd number. So you see this logic, now I'll remove all this logic. The same thing I can do it in 2 lines. I can do it in 2 lines. Okay, using the ternary operator. So how do we do that? For that, I'll define a variable which is of string type. Okay, which is of string type, and I'll name this as result. The variable name I have taken as result. Now, so I'll write a condition. Number ampersand 2. Number ampersand 2 equals 0. Equals 0. If this expression is correct, if this expression returns true if this expression returns true, then take even as an input, or else, okay, that make the result as odd. Make the result as odd. Okay. So now you see that the whole logic I have removed in a simplified format. I explained that my to my compiler in a single line. In a single line. This is like a shortcut notation of explaining or combining two or more conditions. Two or more conditions. Okay. So now number ampersand by 2 is equivalent to 0. Number what it says 9. 9 ampersand by 2, the result is 1. If the result is equivalent to 0, the first value will be picked. Okay. If the result is exactly equivalent to 0, the first value will be picked. If it is not, the second value will be picked. The second value will be picked. So now ampersand by 2, which means the 9 modular by 2, the remainder will be 1. 1 equals to 0, condition failed. If the condition is false, the second parameter will be picked. The result will be odd. The result will be odd. So now here I'll just print. What I will print? Number plus. I'm using a concatenation operator here. I'm combining the integer with a string. Okay. I'm concatenating one more, the result plus number. I'm giving a space. So I am converting now. So I am doing a concatenation and concatenation. I'm using this concatenation operator and printing it. So I'm taking the number 9 is a, okay, I'm 9 is a, and then I'm appending one string, and I'm appending one more string. What is that? Result. Okay. So I'm saying number is a, so 9 is a, if it returns even, then it becomes even. The result will become even. Okay. If the result is odd, the result will come as odd number. Okay. So in my case, in this case, okay, 9 is a odd number. 9 is a odd number. Okay. The same which we have written in 2 lines. The whole if else blocks, everything we have converted into one single line in shortcut notation using the ternary operator. Using the ternary operator. Let us check this now. Okay, there is a problem. There is a typo. Here I have written as result and here I result. There is no variable defined, it says. There is a problem actually with the variable name. So it didn't identify the variable. Okay, you see the result. It didn't find the variable, cannot find the symbol. Okay, exact problem is this result variable. So I'm clearing the screen, compiling the code now. Code has been compiled and I'll run the class. 9 is an odd number. 9 is a odd number. Same thing, right? What we have done in the earlier logic using if else block, I have given it in a shortcut notation. I have taken two conditions. I have taken single condition, evaluated the result. Based on the result, I'm choosing the values. I'm choosing the values. Okay. So for example, if this becomes 10, it becomes 10. So now this will validate the same condition. It will validate the same condition. So equivalent to 0. If it is true, the first value will be picked. The first value will be picked. If it is false, the second value will be picked. Okay. Always Which value to be picked will be dependent on this expression, If true, first value. If false, the second value. So 10 exactly divisible by 2. So the remainder will be 0. So this value will be written as, so if it is true, the first value will be picked before the semicolon. Ten is even number. Now into the result, previously we got, if we give 9, we got odd as the input, because here the expression or the condition has written false. Okay, so that's about the ternary operator. Okay, uses of ternary operator. Ternary operator combines more conditions as single unit. That's the first question. If, sorry, ternary operator takes an expression as input based on the result written by the expression. If true, first value will be picked. If the result is false, second value will be picked. Okay, using ternary operator, code readability will be increased. Code readability will be increased. Okay, that's about the ternary operators. So any questions on this? The instance of operator and ternary operators. Any questions? Any questions? Assuming there are no questions on this, now we'll discuss about the bitwise operators. The last operators that we have, bitwise operators. So if you know logical operators, then you are aware of bitwise operators. So do remember, we remember the logical operators. Logical operators depends on the expressions. Logical operators depends on the expression that returns Boolean values. That will return Boolean values, or it is dependent on, simple to say, it is dependent on Boolean values, right? So what are the logical operators that we have? We have logical AND operator, right? And we have logical OR operator, and we have logical NOT operator, right? So these logical operators operates on Boolean values, and the truth tables are dependent on Boolean values. So the bitwise, so simple to say, it says, okay, it says these operators operates on the bits of the numbers, bits of the digits, bits of the digits. Basically, the bitwise operators are very similar to your logical operators, are very similar to your logical operators, but bitwise operators operates on the digits, Okay. So what are the bitwise what are the bitwise operators that we have? Okay, we have bitwise AND operator, bitwise OR operator, okay, bitwise AND operator and bitwise OR operator, bitwise XOR operator. This is bitwise AND, this is OR, this is XOR, okay, and this is NOT. This is bitwise NOT. And then you have left shift operators, and then we have right shift operators, okay. Then there is a zero fill right shift operator, zero fill right shift operators, okay. So these are the operators that we have. So we'll take a 5-minute break. We'll take a 5-minute break and we'll discuss how these operators will work. So we are very near to 6:30. So we'll take a 5 to 10-minute break and again join at 6:40 to the class. About bitwise operators. Bitwise operators. So the bitwise operators operates on the bits of the digits. So the logical operators operates on the Boolean value. Bitwise operators operates on the numbers. It will operate on the numbers. Okay. So you have AND operator, OR operator, XOR operator, NOT operator. Okay. Right shift, and zero fill left shift. Sorry, zero fill right shift operators. These are the bitwise operators that we have. Okay. So likewise for AND operator, you have truth table, right? So for logical AND, you have a truth table. You have operand 1, you have operand 2, and it will evaluate the result. So if for logical AND operator, logical AND. So how do you identify logical AND? Double AND symbols. That is logical AND. So if first is how, when it will return true, if both the values are true, then only it will return true. If both the values are true, then only it will return true. In any of the case, it will return false, right? This is the truth table for AND, logical AND. This is for logical AND. So the same thing in bitwise, the true is considered as 1. True is equivalent to true is equivalent to 1. False is equivalent to 0. False is equivalent to 0. This is like on and this is an off. Bit and switch off a bit. Okay. You will be switching on a bit here. When there is a 1, when there is a 1 in the place, then you will switch on the bit. When there is a 0 you find, you will switch off the bit. You will switch off the bit. Okay. So the truth table will be converted in case of bitwise AND. In case of bitwise AND. So now you have operand 1 and you have operand 2 and you will have the result. You will have the result. So here true is equivalent to 1. So it means if both are 1, if both the bits are on, then the result will be 1. If any of one bit is off, if any of one bit is off, for example, operand 1 bit is on, operand bit is off, then the result will be off. Then the result will be off. Okay. So if operand 1 is off and operand 2 is on, then also off. If both the bits are off, then it will return off. That's the truth table for bitwise AND. That's the truth table for bitwise AND. Then Anil, how these ones will be deciding? How can we convert? So you are saying bitwise operators can be applied for numbers. They can be applied for numbers. Okay. So when we are applying for numbers, something like this. Okay. Int result is equal to 20 and 30. I can say something like this. 20 and 30. So when I do 20 and 30, okay, this is a bitwise. I'm using a single AND operator here, not double. If I'm using double, that is logical. If I'm using single, that is bitwise. That is bitwise. Now, when I'm using 20 and 30, basically, now it operates on the bits of 20 and bits of 30. So first we have to convert these bits to, first we have to convert this number to bits. So convert the numbers to bits. Bits means you have to convert the number to a binary format. You have to convert this number to binary format. Binary means divisible by 2, right? 2 tens are 0. Result is 0. 5s are 0. 2 twos are 4. 1 is a remainder. 2 ones are then 0. So the bit will be 1 0 1 0 0. The 20 value is equivalent to 1 0 1 0 0, right? So if you do a binary conversion, something like this: 1 into 2 plus 0 into 2 plus 1 into 2 to get the decimal value. To get the decimal value, 0 into 2 plus 0 into 2. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Right? 1 into 2 power 4, so 0 into 8. So 2 power 4 means 16. This is 16. 2 twos are 4, 4 twos are 8, 8 twos are 16. 1 into 16 plus 0 into 8 plus 1 into 2 square is 4 plus 0 into 2 plus 0 into 1. Anything power 0 is equivalent to 1. So it is 16 plus 0 plus 4 plus 0 plus 0, which is equivalent to 20. Which is equivalent to 20. So when you get such kind of things, what you have to do is you have to convert that to the binary. The bits you have to convert, that these numbers you have to convert to binary. Okay. So int will take how many bits? How many bits it will take? Int. Basically, it will take 4 bytes of data. It will take 4 bytes of data. 1 byte is equal to 8 bits. 1 byte equal to 8 bits. So number of bytes we have 4. 4 into 8, which is it will take 32 bits. 32 bits. How many bits we got? 0, 1, 2, 3, 4. Only 4 bits we have got. Right? So which means only 5 bits we have. So all the remaining will be appended with zeros. The rest of the numbers will be appended with zeros. Everything you can add zeros in front of it. Right? So because anything into zero value will not have it. 32 bits you can keep it as 32 bits you can keep it as zeros. So the rest of the bits you can keep as 0. So similarly, you convert 30. You convert 30 value. So 30 means 2 15s are 0, 2 7s are 14, 2 3s are 6, 1 is the remainder, 2 1s are 2, and 1 is the remainder. So the value will be 1 1. You go this way, 1 1. So double 1 double 1 0. This is the value for 30. The binary value for 30 is this. The binary value for 30 is this, right? So double 1 double 1 0. Now on these 2 bits, now this is 20 and this is 30. This is 30. Similarly, now you can do a calculation. 1 into 2 plus 1 into 2 plus 1 into 2 plus 1 into 2 plus 0 into 2. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Right? So 1 into 16 plus 1 into 8 plus 1 into 4 plus 1 into 2 plus, okay, 0 into 1. 0 into 1. 16 plus 8 plus 4 plus 2 plus 0. So how much you got? 16 plus 4 20, 8 plus 2 10. Value is 30. Value is 30. So now you have to convert these numbers into bits. So the number you got is 20 and here the number you got is 30. So now I'm saying 20 and 30. So now you have to, what is the number? 1011 is for 20. Okay, 10100 is for 20. Okay, 0 1 1 1 1 is for 11110 is for 30. This is for 30. So 30 and this is 20. Now apply the truth table on these bits. Now apply the truth table on this. For bitwise, I'm using bitwise AND. So the truth table. What is the truth table for that? If both the bits are, if the bits are on, then the value will be 1. Then the value will be 1. If any of the bit is off, then it is off. Right? 1 0. This is the truth table. Operand 1, operand 2, and this is the result. Okay. 0 and 1 equal to 0. 1 and 0 equal to 0. Both are 0 equal to. Now both are 0. Right? This bit is off, this bit is off. If I apply AND operator here, the result will be 0. This bit off, this is also off. So this is also 0. This bit is on and this bit is also on. Right? Now both the bits are on, the result will be 1. The bit will be on. So now 0 and 1, 0. Both the bits are on. It is 1. You see, now the value is 1010. So the binary value what you got is 10100. So this value what we got. Now convert this to the decimal part. So that is 1 into 2 plus 0 into 2 plus 1 into 2 plus 0 into 2 plus 0 into 2. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Right? 2 power 4 means 16 plus 0 into 8 plus 1 into 4 plus 0 into 2 plus 0 into 1. So 16, which means 1 into 16. This is 16 plus 0 plus 4 plus 0 plus 0. So 4, so 4, 16 plus 4 equal to 20. So the output, what it gets stored, right? The output in the result, output what it gets stored is 20. It will store the value 20. Okay, understood? Similarly, you have to do it for OR. You have to do it for OR. So I have the conversions in place. If you know the OR truth table, okay. Logical OR, if you remember, logical OR. Can someone tell me the logical truth table for logical OR? Can someone tell me the truth table for logical OR? Can anyone tell me the truth table for logical OR? Operand 1, operand 2, and the result. Logical OR. Logical OR. Anyone? Simple. Opposite of AND. Okay. Opposite of AND. So which means if both the bits are off, then only the bit will be off. For example, first case, true and true. If operand 1 is true, operand 2 is true, the result will be true. Okay. If the operand 1 is true and operand 2 is false, then also turn true, because any of one operand is true, then it is true. So if second operand is false, first operand is true, then the result is true. Then the result is true. Result is if both the operands are false, then only false. As per this, you frame now the bitwise. Okay, operand 1 and operand 2 and the result. Right? So 1 is equivalent to 2, 1 is equivalent to 2, sorry, true is equivalent to 1. The bit is on. If both the bits are on, then the result will be on. If any of the bit is on, then also the result will be on. 1, 0, 1. So 0, 1, 1. If both the bits are off, then only it is off. Then only it is off. Now, as per this truth table, we have the conversions, right? When I say int result equal to 20 or 30, 20 or 30. Okay. So we have the calculations in the previous page. So 20 is equivalent to 10100, 10100. 30 is equivalent to 11110. Right? Now apply this truth table on it. Both the bits are off, then bit is off. So if any of one bit is on, then it is on. Okay, both the bits are on. Okay, any of one bit is on. Okay, then the result is 1. Both the bits are on, then also it is 1. So now you see 11110, the result is 30. Right? 11110, if you convert that, the value will be, right? The value will be 30. Okay. So that is bitwise OR operator. That is bitwise OR operator. Now there is one more operator which is called exclusive OR. Okay, exclusive OR. So the exclusive OR is represented with the help of a new symbol called caps. It will be there on top of 6 on your keyboard. On top of that, you can see cap symbol. Okay. So this cap symbol is called exclusive OR. Exclusive OR. Exclusive OR. Okay, this is a bitwise exclusive or simple to say, this is XOR. This we call it as XOR. Okay, there is a truth table for XOR also. Okay, so it is very simple. It's a combination of if and else. If it finds the matching bit, then the result will be false. For example, opposite one and operand 1 and operand 2, you have the result. Okay, now if bit 1 is on, if operand 1 is on, and if operand 2 is also on, So it found exactly the same. Both the bits are on. The result will be opposite. It will off. It will get off. Okay. Now if one of the operand is, if both the operands are opposite, then it will turn on. Then it will turn on the bit. Now 0, 1. So any of one bit is, both the operands are of opposite bits. So it will turn on. So now 0 and 0. Okay, both the bits are of same type, right? Then it will turn off. If it finds, if it finds that both the bits are on or both the bits are off, then it will switch off. Then it will return 0 as the result, which means the false as written. If the both operands are true or if the both operands are false, then the result will be false. If any of one operand is true, then the result will be true. The result will be true. Now you apply the exclusive OR on the value. So int result equal to 20 cap 30. 20 cap 30. So I'm taking the same example. You can take a number of any numbers, but for I can't do conversions for everything. So I'm taking this values and doing it. So 101 00 101 00, then 11 110. These are the numbers. These are the numbers. This is 20. This is 30. So both the bits are off. The result will be off. So now here, both the one of the opposite, find an opposite bit. So this will turn on. Here, if you see, both the bits are on. So it will return false. As per the truth table, return false. So if now one of the opposite bit it found one of the opposite bit turn on. Both the bits are on. It will be turned off. So the value will be 0 1 0 1 0. Now this you convert it. So 0 into 2 plus 1 into 2 plus 0 into 2 plus 1 into 2 plus 0 into 2. So 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. So 0 into 16 plus 1 into 8 plus 0 into 4 plus 1 into 2 plus 0 into 1. 0 into 1. So now anything into 0, this is 0, 8, 0 plus 2 plus 0. So which value will be 10? The value will be 10. In result, the value it will store it as 10. Okay, the value will be 10. That is exclusive OR. So bitwise AND operator, bitwise OR operator, bitwise XOR operators, bitwise XOR operators. This is how they operate. Okay, this is how it gets operated. Okay. So let us see these examples, all the results, what we have got. So move this. I'll keep only the print statement in my code. Now this I'm turning to result 20 and 30, the first one. So here I'm just printing the result. I'm just printing the result. So now your compiler sees that you are using a bitwise operator, and now the code will compile. The code gets compiled, right? The code gets compiled, and after that, when your JVM is executing, JVM will convert these numbers to binaries. JVM will convert these numbers to binaries, and it operates on the bits, and it operates on the bits, and the result will be evaluated based on that bit as per the truth table logic. As per the truth table logic, your JVM will execute as per the truth table logic, and the result will be stored inside this, and that it will print it here. Saved. The code has been compiled. The result is 20. In the case of and, we also got the result as 20. The result as 20, right? In the case of AND operator. In the case of AND operator. Now, the same logic I'll change to OR, single pipe. So now when we do it OR, now these bits converts and it will apply the truth table of bitwise OR. So when we applied this, the result we got it as 30. The result we got it as 30. The result is 30 as per the calculation. I've done the calculation. As per the calculation, it is 30. So internally it does the calculation. Okay. Exclusive OR, cap, exclusive OR. Now when it finds exclusive OR, it finds the truth table of exclusive OR and it applies on top of the bits, and the result for this is we received 10. The result is 10. See, the result is 10. Okay. So basically you have to think like the interpreter. You have to think like the interpreter, and you should remember this truth tables. Very simple tables. So when you see a bitwise AND operator, it converts into the bits and it applies the truth table on top of it. Blindly it applies the truth table and again it converts to the decimal, and the decimal value will be given back as a okay. So it is about bitwise AND, bitwise OR, and bitwise XOR. And one interesting operator we have, which is NOT operator. We have one more interesting operator, the NOT operator. This is a very interesting operator. Okay. So you know about NOT operator, right? NOT operator, logical NOT. If I say yes, it will say no. If I say true, the result will be false. If I say false, then the result is true. Then the result it will written as true, right? Logical NOT. But in case of bitwise NOT, okay. So you can find this symbol. This is called a tilt symbol. This is called tilt. This is called a tilt symbol. This is called tilt symbol. So this tilt symbol is called as bitwise NOT. It's very interesting operator. It is very interesting operator. So when I apply bitwise NOT for any number. So what it does is the result always it will take the number. It will do something like this: number equal to number plus 1. It will add 1 to the number. It will add plus 1 to the number, and it will return the value. Okay. And it will return the value. So one interesting thing here is, okay, it will add the number, right? It will add the number. Now, if this is a positive number, right? It is a positive number. This positive number will be converted as a negative sign. It will convert it as a negative number. Okay, something like this. When I say 198, 198. So number equal to minus of number plus 1, number plus 1. Okay, so this is a shortcut notation. This is a shortcut notation. So now number is equal to, for example, number equal to 198. If I take now, it will, what it does is, okay, take this 198 plus 1, it will add, final result is 199. Okay, if this number, if the result is positive, if the result is positive, then it will give a negative value, which means it will return 19 minus 199, minus 199. If the same thing, if there is a negative number, for example, if I apply it for minus 197, okay, for minus 197. So now what it will do is it will add plus 1 to this, minus 127 plus 1. So plus 1, this is a negative number, so the value will become, the result will be minus 196. It will decrease. If you add 1 to the minus number, it will decrease, minus 196, it becomes minus 196. So the result, at the end, the result, it has found it as negative. This negative value will be converted to positive. The sign value will be changed. Now the result will be 196, positive 196. First it will add plus 1 to the number. If the number is negative, it will convert to the positive. Okay, if the result is if the result is positive, then it will convert to the negative. That's how the not operator, bitwise not operator behaves. Okay, bitwise not operator behaves. Okay, so something like this. Bitwise operand is equal to, okay, minus of, okay, minus of operand plus 1, something like this. Okay, so why I'm saying plus or minus, this is plus or minus of operand. This is a plus or minus, because if it is a negative, then it will convert to positive. If it is positive, then it will convert to negative. So now, as per this rule, if I say result is equal to 30, result equal to 30, now apply the bitwise operator for the result, right? So the value is 30. So it will first add plus 1, 31. The result is positive, right? The final value is 31, which is a positive. So it will convert the sign from positive to negative, positive to negative. So this becomes now minus 31. The result will be minus 31. Code has compiled. See, it has added plus 1, and the result final value is 31, which is a positive value. So it has converted to negative value. The same thing, I'm giving it as minus 30. I'm giving it as minus 30. So now result equal to minus 30 I have given. So minus 30 means minus 30 plus 1. The final result will become minus 29. So the final value is minus 29. It's a negative value. It is converted to the positive, which means the result will be 29. The result will be 29. Compiling the code, the result is 29. Okay, that is bitwise not operator. Bitwise not operator. Okay. So then you have left shift operators and right shift operators. You have left shift, sorry, not this. Okay, double less than indicates left shift. Okay, less than indicates, okay, it's a relationship operator. Less than is a relationship operator. It's a relationship operator. Okay, less than or greater than. If you see double less than, then it is Okay, left shift operator. Left shift operator. If you find double greater than, this is right shift. Right shift operator. So the name itself says shift the bits, left shift. So shift the bits to the left side. Shift the bits to left side. Okay. Right means shift the bits to right side. Shift the bits to right side. Okay. So as simple as it. So for example, okay, I have the value 20. I have value 20. So now what I'm saying is, okay, shift, I'm doing a left shift first. So the value of 20 is 10100. This is the binary value. So when I'm saying shift the left shift this by 2 bits. Left shift this by 2 bits. So when okay, when I say this, left shift the numbers by 2 bits. Now think that this is how the bits are stored inside the memory. 0, 0, 1, 0, 1, 0, right? Sorry, this is 1. This is 1. So when I say int x equal to 20, int x equal to 20, x left shift by 2 bits. So I'm saying, okay, 2 bits of x has to be moved to the left side, and rest of all the values. Okay, it is a 32 bit. How many bits we filled? 1, 0, 1, 2, 3, 4 bits only we filled. So how many are remaining? So 32 bits. Think that this is one. This box is one single bit. So these are 4 bits I have filled, which means I still have 27, right? 28. So 0 means 5 is completed. 5 is completed, right? So 27 plus 5, 32, right? 32. So I still have 27 bits. I still have 27 bits here. Okay. So which is filled with zeros, Now I am saying do a left shift by two digits, right? Do a left shift by two digits. So which means, so these two bits will change its position. Okay, it will move their position. So something like this. So think that this is again one more. I am saying the numbers shift by 2. So which means these numbers will be shifted. So something like this. The first one, second one, third one, fourth one, right? 0, 1, 2, 3, 4, 5, 6, 7, and so on. Think that you have till 32. You have till 31. Okay. So now when I say left shift by 2, the 2 digits, the last 2 digits, these two numbers will be moved towards the left side. It will move towards the left side, which means these two numbers, 0, in 0th position we have 0, in 0th position also, in first position also we have 0. These two will be moved to the second bit. It will move the condition here. Left shift by 2 I am saying. So it will move towards the second bit. It will move towards 2 bits, it will move forward. 2 bits, it will move forward. So now 1 will be copied into the third bit. 2 will be copied into the fourth bit. 3 will be into the fifth. 4 will be into the sixth. Okay. And so on. It continues. The copies. Now these 2 bits, what you have, we have shifted these 2 bits. Last 2 bits, we have shifted their positions. We have shifted their bit positions. Now the last 2 bits are left out. These will be filled with zeros. These will be filled with zeros. Now you look at this. The number becomes the value of 20. When I shift it to the left side, the number becomes 101, 101. This is 0, right? 101, 0, 0, 0, 0, right? This becomes the number. This becomes the number because it will add two digits, 2 zeros at the end. 2 zeros at the end. When you the number of digits that adds at the left side, what happens? What happens to the exponent value? It increases. The bit value gets increased, right? This is 2 power 0. This is 2 power 1. 2 power 2, 2 cube, this becomes 2 power 4, 2 power 5, this becomes 2 power 6. 2 power 6 means 2 power 4 is 16, right? So 5 is 32, 2 is 32, that becomes 64. This value will become 64 plus 16. The value will become 70, right? Sorry, 80. It becomes 80. You are shifting the bits by the number of positions, by the number of positions. Similarly, right shift, okay, right shift will be moved to the side. The last two digits will be removed from here, okay. So if I say 20 right shift by 2, from now the bits will be moved from right side. It will move from right side. This you remember this. Left means we are doing it from the left side. We are doing it from the left side. Right means we are moving it from the right side. We will move from the right side. Okay. Similarly, zero fill right shift. Similarly, zero fill right shift. So what it means by zero fill right shift indicates here. Assume that you are shifting a bit by 64 bits. You think that you're moving the bit by 64 bit. Okay. The last bit is called sign bit. If you remember this, the last bit is called sign bit, which will decide which is a positive or negative number. If the last bit is 1, if the last bit is 1, then it will be a negative number. If it is okay, if it is 0, then it will be a positive number. Something like sign will be decided, positive or negative, positive or negative. Okay. So in case of right shift, everything will be filled with 0. There is no negative value that you get it, that you get it. So in case of right shift, you only will have positive values. You only will have positive values. In case of left shift or right shift, it can be a positive number or it can be a negative number based on the number of bits that you shifted to left or right, left or right. Okay. So try to shift the bits. Take for example byte value. So because byte will have only 8 bits, right? Byte b is equal to 20. So now when I do this, I'll have only 8 bits. The positions is 0, 1, 2, 3, 4, 5, 6, and 7. So the value is 0, 1, 0, right? So the first is 0, 0, 1, 0, 1. Rest of the values are filled with zeros. Rest of the values are filled with zeros. Now when I say 20 right shift by 2. So make a copy of it. So 1, 2, 3, 4, 5, 6, right? So when I say shift by 2, so these two numbers are filled with zeros from the left side. These digits will move towards this. So here it will copy 0, here it will copy 1, okay, here it will copy 1, 2, okay, sorry, this is 0, this is also 0. I have taken this bit value, the actual value is 0. So here it will take 1, here it becomes 0, into the here it becomes 1, and the fifth value, the fifth value 0, and these two will be deleted. These two will be deleted from the right side. These two are deleted from the right side. They are moving outside. There is no space. So these two bits will be deleted. Okay. Similarly, when you do it to the right shift, if you do it to the right shift, 20 right shift by 2. Now take this. This is 0, 1, 2, 3, 4, 5, 6, and this is 7. Okay. So the value is 0, 0, 1, 0, 1. So rest of the values are zeros. Rest of the values are 0. Well, so when I say right shift by 2, right shift by 2. So now something like this it happens. 0, 1, 2, 3, 4, this is 5, this is 6, one more. So now I'm right, I'm doing a right shift. I'm doing a right shift, which means, okay, these numbers, this time I'll fill from the right side. Okay. So what I'm doing is, so the two positions I am shifting it. Two positions I am shifting it, which means these rows I am moving by 2 bits. So it will start filling something like this. So 7 and 6 is removed off, and then on the fifth position 0 is filled. On the fourth position again the 0 is filled. Okay. On the fifth position the 3, here also the 0 is filled. Okay. So on the fourth position which comes the 1, okay, then 0, then 0, then 1 will be filled, right? So if you take this is the 1, then this is the value, and this is the value. So these two bits from the left side are removed. From the left side are removed. These two bits, what is left out is removed. And these values, whatever will add at the right side. So two zeros will be added at the right side. Now this becomes 1 into, so basically all are zeros. This becomes 101. This becomes 101, right? So which means 1 into 2 square plus 0 into 2 power 1 plus 1 into 2 power 0. So 2 square is 4, 4 plus 0 plus 1. This becomes 5. The value becomes 5. Okay. The value becomes 5. That is left shift and right shift. The number of the bits that you move, the number of the bits that you move either from the right side or from the left side. Okay. These are not much, left shift and right shift or zero shifts are not much useful operators. But if you are dealing with, if you are dealing with a, like if you are doing this uh, gaming kind of programs, then these will be helpful for you a lot. For example, you have to shift this to the left side, to the right side. Maybe if you wanted to do that, shift these bits by this many bit times, then it changes that positions of the game, basically the game. For example, you're driving a car, right? So if you do a click to your left side, then it will shift the bit by one, so that the position of that car will move to left side or to the right side by one click, something like this. So this is more doing a gaming kind of programming. These bitwise operators will be useful for you when you're really operating on the bits. Maybe if you're doing some board designs and all, okay, then these bitwise operators are useful for you. But bitwise and bitwise or bitwise XOR or not will be helpful for you. Okay, but not the left shift or right shift as much as possible. They are not much useful operators. So that's about the operators. So any questions on this? Any questions on this? Any questions on this? Assuming there are no questions, so we'll, if there are no questions, we'll wind up this session. Very close to close these fundamentals. So next we have only the loops or the control statements. We have the control statements and the loops. With that, we'll close the fundamentals. Then we'll move towards the object-oriented programming. Thank you. Thank you, everyone. Today, we'll continue the Java session. So the same Java session will continue. So we'll not have the DS class today. So in last session, we discussed about the operators. We discussed about the operators. So we have completed the operators completely. So now we'll move further towards, okay, the important item. One more new topic. One more new topic called control statements. Okay, we'll move towards the control statements. So I'll share my screen. Hope you can see my screen now. Hope you can see my screen. So, so we discussed about in last session, we discussed about operators. Now, now we are discussing about control statements. Control statements. Okay. So these are very important. These are very important. Control statements are very important because the name itself says control, right? So these will control the flow of execution, the flow of code execution in Java. It will control the flow of code execution in Java. Okay. So basically the control statements, okay, in control statements, you can control the flow of your execution. Okay. So there are three type of control statements. There are three type of control statements. What are those is, okay, one is conditional control statements. Conditional control statements. And the second is loops. Okay, loops or looping control statements. Okay, loops or looping control statements. And third is unconditional control statements. Unconditional control statements. Okay. So these are the control statements, basically control the flow of execution. Flow of execution. For example, let's say I'll take a use case or a scenario here. Use case or scenario. So think that you are logging into Gmail. You're logging into Gmail. When you log into the Gmail, what you provide? You provide a username and you provide the password, right? You provide the username and you provide the password. Now, what happens if I enter a wrong username? What happens if I enter a wrong username and wrong password? What happens? This is a general scenario. Take, for example, your mobile. Take your mobile. What if I enter a wrong PIN? Right? What happens if I enter a wrong PIN? It will not allow you to log into the system. Right? It will not allow you to access your data on your mobile. Right? Somebody is controlling it in the background. Somebody is controlling it in the background. Who controls this flow? Is like your control statements. Your control statements. Your control statements. Okay, the control statements plays a key role. Plays a key role. How the application has to behave. How the application has to behave. So, for example, when I give a right correct details, then take me to the home page. Take me to the home page. Okay. If I give a wrong details, if I give a wrong details, then then it will give you some error messages. So the control statements basically controls the execution of your code. Controls the execution of your code. So if you look at the control statements are divided into three types. Control statements are divided into three types: conditional control statements, looping control statements, and unconditional control statements. What will fall under conditional control statements is if statements, and switch statements. Switch statements. These are not loops, these are statements. If is not a loop and switch is not a loop. Okay, these are conditional control statements. Okay, if is not a loop and switch is not a loop. Okay, so when it comes to the looping, okay, so the looping you have is for, you have a for loop, you have a while loop, and you have for each loop. You have for each loop and you have do while loop. You have do while loop. For loop, while loop, do while loop. For each is an advanced format of for loop. It's an advanced format of for loop. That's it. So in case if you wanted to do repetitive tasks, if you wanted to do repetitive tasks, then you will go for looping statements. You go for looping statements. Okay. Unconditional control statements. See, it is saying unconditional control statement. So something should break the flow, right? Something should break the flow. Or somebody, if I'm saying something, I should skip something and continue it. Okay. Let's say if I'm explaining something, or if I'm doing some action, some of the actions has to be skipped and some has to be performed. Okay, those statements are called unconditional control statements. What will fall under unconditional control statements is the break and continue statements. Break and continue statements will fall under unconditional control statements. Unconditional control statements. So control statements basically controls the flow of execution in Java, and there are three types: conditional control statements, loops, and unconditional control statements. So conditional control statements are if and switch. These are conditional control statements. Loops. So basically, if you want to perform anything in a repeated order. So basically, any hotspots. If you want to write the hotspot code, right? Doing the same activity, in a loop, in a loop. When you want to write the hotspot code, Java hotspot code, you will use the loops. You will use the loops. So what are loops we have? For loop and while loop. Mainly for loop and while loop and do while loop. Do while loop. So when it comes to the unconditional control statements, if I want to break the loops or if I want to break the flow, then I'll use the break statement. If I want to skip some of the actions and continue my flow, continue my loops or continue my flow, then I'll use continue statement. Then I'll use continue statements. These are control statements. Okay. So first let us discuss about conditional control statements. Let us discuss about conditional control statements. So when it comes to the conditional control statements, these are also called as decision making statements. These are called as decision making statements. These will take decisions. Okay, these will take decisions, or these are also called as selection statements. These are also called as selection statements. There are different names for it. It can be a conditional control statement, or this is a decision making statement, or these are like selection statements. These are like selection statements. The name itself says it's here the decisions are being taken based on some condition, based on some conditions. Okay. So the decisions are made based on some conditions. Always you take in the real time, any example, if you take a decision based on some input, right? For example, to take the scenario of today, no ds class, then take Java class, then take Java class. So there is a condition, no ds class. The condition is if there is no ds class, then take the Java class. Okay, if there is no college today, then you take a decision there. Either you go home or you go for a movie. You go for a movie, right? There is a decision making statement, right? Control statements actually will decide or will decide based on the condition, based on the condition. So if there is no college and if I have some money, I'll go for movie. So the condition is no college and input is money. Input is money. Then I'll go for a movie. If there is no college and if I don't have money, I'll go home. I'll go home. So now the decision I have taken that no college, no money, I'll go home. Right? Something like this. Okay. So the conditional control statements executes based on the conditions. They gets execute based on the condition. They are dependent on the condition. They are dependent on the condition. Okay. So the execution of these control statements, the execution of these control statements always depends on the result of the condition. Depends on the result of the condition. Okay. So the execution of these control statements always depends on the result of this condition. Okay. So always based on the result of the condition, the decision will change. The execution will change. For example, username incorrect. Show the error. Show the error. Password incorrect. Say incorrect password. Say incorrect password. Username and password is correct. Allow for login. Allow for login. So in simple term, I'll explain you. Okay. So you go to a theater, purchase a ticket. Okay. If ticket is valid, gatekeeper will allow you to go inside. Right? Gatekeeper will allow you to go inside. If ticket is invalid, throw outside. So here the gatekeeper is deciding now the flow of the who is entering into the theater. Right? If ticket is valid, so if ticket is true, allow him to log in. If not valid, throw him outside. The decision is made by this gatekeeper based on some condition output. Right? Now go to the movie theater. Okay, I'm going to a movie theater. Okay, if tickets booked online. Okay, if tickets booked online, don't wait in the queue. Don't wait in the counter. No waiting in the counter. Okay, no tickets. No tickets in counter. Then what you do? Go for black. Right? You're taking a decision. No tickets in black. Turn back home. Right? This is how you take decisions. Right? The same thing, if your program has to take a decision, these conditional control statements will help you to take the decisions. So what are the conditional control statements that we have? We have if and switch. If and switch. Okay. So there is a syntax for if block, if statement. There is a syntax for switch statement. Okay. What is that syntax? We'll see now. So this is like if I have some money, I'll purchase home. Else I'll take a home for rent. Something like this. Okay. So so there is a syntax that is defined for the if block. What is the syntax is? So it should start with a keyword called if. If is a reserved word. If is a reserved word or keyword. And if takes some condition as an input. If takes some condition as an input, and there should be an opening brace, and there should be an opening brace, and the statements, you have to write the statements inside it, whatever the statement, whatever the logic that has to be executed if this condition matches. If this condition matches, those you will write inside it and you'll close it. This is called simple if statement. Simple if statement. Okay. So you will use a if keyword. You use a if keyword, and then you write some condition. If the condition is true, then only these statements will get executed. So to remember, the condition must evaluate a Boolean value. Must evaluate a Boolean value, that is either true or false. True or false. The condition must evaluate either true or false as an output. As an output. If it is true, then only these statements get executed. If it is true, then only these statements get executed. Something like this. The decision making. Maybe if you have attended the DS, there in the flow chart he might be giving you. There is a Boolean expression. There is a Boolean expression. Now, if it is true, okay, if it is true, then execute the if block. Execute the if block. False, right? Stop the loop. Okay, if it is true, execute the statements of if block, execute the statements of if block, and then stop the execution. If it is false, just directly don't execute the if block, just stop it there itself. Stop it there itself. So the Boolean expression will decide, okay, the Boolean expression will decide the statement's execution or not inside an if block, inside an if block. Okay, if the condition is true, then only the if block statements will be executed, and only once it will be executed. Only once it will be executed. There is no iteration over here. Iteration means there is no looping here. Decision is only taken once. Decision is only taken once. Okay, for example, travel home by car or by bus or by train. Okay, you have to decide it to book a ticket or to book a cab, right? If the decision is taken, if the cab is booked, then I cannot say, okay, I by mistake I booked a cab. I cannot say by mistake I booked a ticket. You already have taken a decision and you booked it. Okay, if the condition matched, it gets executed. That gets executed. Flow cannot be okay, once the condition is satisfied, okay, you cannot control these statements. These statements will execute automatically. These statements will execute automatically. Okay, this is a simple if statement. This is a simple if statement. Okay, now there is one more statement called if else. In case if the condition is false, in case here the condition is false, the condition has written the value as false, then some default statements I have to execute. That is with the help of else I can do. That is with the help of else I can do. So the syntax for if statement you already know. If condition, then opening brace, then then your code, the statements that gets executed in the if block. After that, you write a else block, and then the default statements. Statements of else block. Statements of else block. Closing brace. Okay. You have if condition, inside that you will write some statements. So if the condition is true, if statements are executed. If condition is false, by default the else block condition, else block statements will get executed. Else block conditions will get executed. So this is the syntax for if else. This is the syntax for if else. Okay. So there is one more, which we called, okay, else if statement. Else if statement. This is called if else if statement. If else if statement. Okay. When you want to validate multiple conditions. When you want to validate multiple conditions. So one is simple if loop, which will have only if, which means if block can withstand without else block. If I don't have a else block also, no problem. Okay, if I only have if statement, that will execute happily. But else statements, if you see the else statements, without if block, you cannot write an else statement. Without if block, you cannot write a else statement. Okay. Similarly, you have if and else if. Okay, this is called if else if block or if else if statement. If else if statement. So the condition is something like this. You have if block and condition 1, then statements, then you have else if block, you will have a condition 2, then statements, then again you can write an else if block, a condition 3, the statements. Finally, if any of these conditions are not matched, else block and statements of it. Okay, this is how the syntax of if else if is framed. Okay, and always remember the condition in any of these cases will return the boolean value. It will return the boolean value. Okay, the condition must return the boolean value. Okay, either any comparison that you do, you use any relational operators, or you can use anything there. Okay, the result has to be the boolean value, and only when you have multiple condition, only one block will be executed at any point of time. Only one block will be executed. Example, book a ticket, by bus, by car, travel by car, by bus, or by train. Else there is no option. So by air. Finally, by air. If any of these are missing, finally travel by air. Right? So only one condition. If you go in bus, then you cannot travel in car or train or air. Right? So only one condition gets executed. Only one condition gets executed. When you have multiple conditions to be validated. When you have multiple conditions to be validated. Okay, this is elif statement. So you have a simple if statement, you have a simple if statement, and you have else if statement, and you have if else if statements, if else if statements. Okay, and similarly, if can withstand without else or else if blocks, without else or else if blocks, you can write if block directly. But else block, if you want to write a else block, and if you want to write a else if block is mandatory. If block is mandatory. Without writing if block, you cannot write any else if conditions or else conditions in the code. Else conditions in the code. So let us do one small example for this. I'll take a new class. So I'll name it as if statement. The class name I gave it as if statement. So now I'm taking these two variables, byte b equal to 20, so byte b equal to 10 and byte b1 equal to 20. So now I'm writing a simple if statement. So here in condition, right? In condition, I'm validating it. The condition I'm validating it. So what is I'm validating? B less than B1. B is less than B1. If B is less than B1, what I'm saying, system dot out dot println of B is smaller than plus B1, smaller than B1. So I'm saying, okay, 10 is smaller than 20. If the condition is success, if 10 is less than 20, then this statement get executed. This statement get executed. Or else I'm taking, what I'm doing, I'm just putting this statement outside. One more, okay, one more I'm writing. Outside the if statement, outside the if statement. If the condition matches, this statement will be executed. If the okay, if the condition matches, if this statement will be executed. Okay, if the condition doesn't match, then only this statement will be executed. So if condition matches, you will have two outputs. Okay, 10 is less than 20, and next it will print outside of the if block, outside of the if statement. Okay, if the condition is false, then it will not execute this statement, it will only execute this statement. It will only execute this statement. Let us see that. I have to save this. So I'll take the class name. So I'll save this class as if statement.java. So now I'll clear the screen. If statement.java. The code is compiled. Java space. I'm running the code. So you see now it is printing 10 is smaller than 20, and after that it is printing. It came out of that. That statements are executed, and the next statements it continued to run. It is outside of if statement. Now I'll go and change that condition. Now I'll go and change the condition. So I'll make it as 10 greater than 20. 10 greater than 20. So 10 greater than 20 I am saying. So this is not correct. 10 is not greater than 20. So the expression will give me false as the output. False as the output. So this statement it will not execute. Now only this statement it will get executed. Compiling the code and executing it. You see, previous case the condition matched, so it has executed the statement. Now the condition didn't match, so this statement is not executed. This if block statement is not executed. It only executed the statement which is outside of the if block, outside of the if block. So if you look at this code, I have only written the if block. I have only written the if block. I have not written else block here. I haven't written any else block. So now I'll say something. I'll add an else block. I'll add an else block. So here I'll change this as, okay, inside else block. Inside else block. So do remember, if the if block code is executed, then else will not get executed. If block code is executed, then else block code will not get executed. So I'm changing condition back again. I'm saying 10 is less than 20. 10 is less than 20. So this will return true. So the if statement is executed. The if statements are executed, but not the else block statement. I'm writing the else block here. So else block starts from here and ends here. Okay. So any statement that you write between start and end of this block, that those will fall under those blocks. So now the if statement will get executed because it is returning true. So now else block statement will not get executed. compiling the code, executing. See, now it says 10 is smaller than 20. Okay, the condition is valid and satisfied. Okay, condition is valid and satisfied. It has executed only the if block statement, only the if block statement. Now I'll make the condition something like this. B is greater than B1. Okay, now the condition is false. Now the condition is false. So if statements are not executed, then only the else block statements is executed. Sorry, if statement check. Inside else block. Inside, see, if you see here, the condition is true, the if block statements are executed. Here the condition is false. Now if statement didn't get executed and the else block statement is executed. So with this we can confirm if block statements only executed when the condition is true. Only the condition is true. Even else if is also the same. Else if is also the same. Okay, so I have b greater than b1. b greater than b1. Now before that I write an else block, else if statements. I'll just remove the if block and I'll just write an else block. I'll just write an else block. So now since there is no if block, you cannot write else block. Else block must be followed by the if block. Else block must be followed by the if block. So alone else block you cannot write. Alone else block you cannot write. Now I'll try to compile the code. See, it says there is an error. Your compiler says there is an error. Boss, there is a else without if. There is a else block without if. If you want to write else statement, if you want to write else statements, it must be written with if statements. And if statements returns, if statements didn't get executed, which means the condition has evaluated false, then only the else will be executed. Okay, that's about that's about if else block. So now I'll write else if statements. Else if b less than, or I'll just paste the code again. I'll just paste the code. Instead of if, I'll write else if. I'll write else if. Okay. Now I'll try to compile the code. You see, it still says else without if block, or assuming that this else is creating a problem. This else is creating a problem. Let me remove this. It still thinks that, okay, you see that it now it says, okay, there is a else without if statement. I don't have that, but ideally I don't have that in my code. I don't have that in my code. I only have else if statement. I only have else if statement, but it still thinks that there is a else statement without if block. So where it is coming? Here it is coming. Okay. So, so let me add a if condition here. Let me add an if condition. I'll take the same code. I'm copying it, the above. So here I'm saying b greater than b1, b greater than b1. Here I'm saying b1 greater than b. I'm changing the condition. So now I'm saying in the first condition, it didn't get it. I'm saying 10 is greater than 20. Now I'm saying b1 is greater than b1 is greater than b, right? So here first condition, okay, b 10 is greater than 20, I'm saying. So the condition evaluated false. This statement will not get executed. Next, it will go to the else if statement. Then it will validate the condition. So here I'm saying 20 is greater than 20. So 20 is greater than 10. So the condition is satisfied. So now this statement will get executed, but not this statement. Only this statements get executed. Okay. Always do remember, in if, or else blocks, when you're using, only one condition will be evaluated. Always based on the condition which is true. Which is true. Simple. Now I'm trying to compile the code. The code has been compiled because all the rules are satisfied. You have if statement followed by else if statement, and that is followed by else statement. Now Java space if statement. See, it is saying 20 greater than 10. So here the condition has satisfied. Here the condition has satisfied. So this logic has been, this statement has been executed. Now when I say okay, something b1 is less than b, b1 is less than b, I'm interchanging the variables here. Now here I'm saying 10 is greater than 20. Here I'm saying 20 is less than 10. 20 is less than 10. Same condition. Okay, both will return false. If this is not executing, then it will go and check this condition. If this is also not executing, then finally the else block statement will get executed. Inside else block. What if the first condition itself satisfies? What if the first condition is satisfied? And now the second condition also. So first 10 is less than 20. 10 is less than 20. This will return true. Now in the second statement, 20 is greater than 10. This is also correct. So both are correct. Now will it execute this statement and this statement both? No. It will only execute only one block. First, which one is it find a match. If it find this match, then only if that condition will be executed, then next conditions it will not execute. Wherever it finds the first condition, wherever it finds as valid, only that condition will be executed. Rest of all of them are ignored. Rest all of them are ignored. So in this case, this is also correct and this is also correct. But at the very beginning, your JVM found this condition is true, only this logic will be executed. Only this logic will be executed. Else if will not get executed. Wherever it finds true, that only first one which it finds true, only that statement will be executed. Compile the code. You see, only the first statement, only the if block is being executed. It is not executing else if block because the control it find this condition is true, only this has been executed. Okay, this has been executed even though this condition is evaluating true, but it didn't execute because the flow will end automatically here, and the rest of the statements will be, rest of the conditions will be ignored. That is about that is about if statement or if blocks. Okay, so basically these are the decision making statements. These are the decision making statements. Now I have taken variables. In the similar place, you take username. String username is equal to, okay, think that this is coming dynamically from the application. Okay, so my username is something like Anil Kumar dot p. Anil Kumar dot p. Okay, and I have a password. Think that there is a password that I'm getting. So password is 1234. Think this is the password I passed dynamically from the front end. So in your application screen, you entered a username and you entered the password as 1234. Now here I'll validate a condition. If username dash dash exactly equal to Anil Kumar. If it is exactly equivalent to Anil Kumar, okay, then what I'll say, username is valid. Username is valid. Now here I'll write password. I'll validate password. Password is exactly equivalent to 1234. Think that this 1234 is coming from the database. Somewhere you stored in the database, and this value also is coming from the database. Whatever the user has passed, right? Whatever the user has passed, anilkumar.p. Okay. So now if the username is done, so you say that this is username is valid. Now, if I wanted to validate, the password, I cannot write a else if block. I cannot write a else if block because only username will be validated. For password, I have to write another if block, another if block. So you can have multiple number of if blocks in the code. So now if password is equal to 1234, now you say password is correct. Okay. So username you validated, password is you validated. If username and password didn't match, in the else statement, you'll return as invalid credentials. You'll return something like invalid credentials. So first condition, you validated the username, and in the second condition, you validated the password. After validating the password, you say you print or you take him to the screen. Just I'm printing it. Okay. I'm just saying, okay, welcome to Nimra College of Engineering and MCA, something. Okay. So this is a welcome message when you validate the password. If your username is invalid or if your password is invalid, okay, then okay, if username is invalid or if password is invalid, it goes to the else statement. Okay. So here now if you see, I have if statement, I have if statement, this gets executed. This gets executed. Then it will not, then it goes and verify for the password. Then it goes and verify for the password, right? Another condition for the password. So what if I have inside if I can have inside if one more if. So now first it will validate the username. If username is valid, then it says username is valid. Then inside this if statement also I can have one more if statement. I can have one more if statement. This is if inside, okay, inside if statement, I have one more if statement. This is called nested if. This is called nested if. Now, this will be exactly the valid condition. Previously, the else block we have only written for example, if I close this block over here. So the if statement opened, started here and closed here. There is no else statement for this. For this if block, there is no else statement. Now, the else statement what I have written will fall under for the password, will only fall for the password, right? So I cannot say, okay, if the password is valid, allow him to do it, right? I have to validate the username also. I have to validate the username also. If username is valid, then go and verify the password. Go and verify the password. For that, you can do one more thing, which is like a nested if condition you can write. So if username is valid, then go and validate the password inside it. If both are valid, then print this. If username is invalid, then directly go to the else block and print invalid credentials. Invalid credentials. So let us save this code. See, the username is valid and password is valid. Okay, both the conditions are correct. Welcome to Nimra College of Engineering, it said. For example, the username I entered thing that I have received as Anil Kumar and password I gave it as 1234. Password I gave it as 1234. Okay, so now you see, compile the code, invalid credentials. It is saying Username is, I entered a username as invalid. Now it says invalid credentials. This is how your applications returns, okay, the output to your front ends, output to your front ends as a response. It takes the input and it validates the conditions. It validates the condition and then it return back the response. So the decisions are made whether to allow him to the login or do I need to block. Okay, decisions are made here. Okay, you can have if statement, else statement, and you can have if statement, else if statement, and else statement, or you can have one if block can have multiple if blocks inside it. So which is called nested if statement. Nested if statement. Okay, so that's about the if block statements. So any questions on this? Any questions on this? Any questions? Cool. Thank you. If there are no questions, then we'll wind up a bit earlier. So we'll wind up the session now and we'll meet again in tomorrow's session.